Hey everyone, welcome back to the channel. Today we are diving into a fundamental concept in system design, which is a stateless versus stateful services. Understanding the difference between these two is critical for building scalable and resilient systems. F- um, we will discuss in this video what they are, their pros and cons, and when to choose one over the other. So let's get started. Let me just make a lot of space for us to read. So, what are stateless service? Stateless service are services where each request is treated as independent transaction with no knowledge of previous requests. The server doesn't maintain any client information between requests. A great example of a stateless service is a REST API. Each time you make a request to a REST endpoint, the server processes it without needing to know anything about previous requests. This independence makes stateless services easier to scale because each request can be handled by any server. So, there are some characteristics about the stateless. The first thing, which is independent requests. Basically, each request carries all information the server needs to process it. Second, which is no server-side session. The server doesn't store information about the client at all. Third, easier to scale because each request is independent. Load balancing becomes straightforward. Any server can handle any request basically. And let's start talking about what are stateful services. Stateful services are services that maintain a state between different requests from the same client. The server remembers some information, such as user session, which makes it necessary to keep track of client-specific data. A common example of stateful service is a chat application. When you open a chat app, the server needs to remember your active sessions, who you are talking to, and the messaging that have been exchanged. This kind of state maintenance is critical for a smooth user experience. Um, okay, let's talk about some characteristics of the stateful service. First, we have the session persistence. The server keeps track of the client's state between requests. Second, we have the complex to scale. Scaling stateful services can be challenging because you need to ensure that requests from a specific client are routed to the correct server holding that state. Third, maintenance context. The server can provide a more tailored response because it knows the client context. Okay, now we need to talk about comparing stateless vs stateful. First, we need to talk about the scalability. Okay, in terms of scalability, stateless services are inherently easier to scale. Since each request is independent, you can add more servers to handle the load without worrying about managing user state. For instance, if you have a REST API that serves millions of users per minute, you can simply add more servers behind a load balancer, and each one can handle requests without coordination, for example. In terms of the stateful services, on the other hand, require careful scaling because state must be maintained between requests. You need mechanisms like sticky sessions to ensure that the same server handles all requests from a given user. Second, we need to talk about reliability and fault tolerance. So, stateless services are generally more reliable. If one server goes down, the load balancer can route requests to another server without any loss of context, since no state is stored on the server. In the stateful services, if the server holding the session state goes down, that user session is lost unless you have implemented a techniques like session replication or sharded session storage using Redis or another storage solution. Okay, let's talk about the use cases. In terms of the use cases, stateless services are perfect for REST APIs, web servers that serves what? Yeah, web servers that that serve static content, microservices that handle individual transactions. In terms of the stateful services, are ideal for chat applications, online gaming, where you need to track player state, e-commerce checkout sessions where user data must be retained. Let's talk about some challenges. Let me just put space here. So yeah, let's talk about some challenges handling challenges of stateless and stateful services. So handling state in stateless architecture. This is one of the biggest challenges in the stateless. One of the challenges of the stateless architecture is handling scenarios where state is actually needed. And a common solution is to externalize the state by storing it in a database or in-memory cache like Redis. For example, instead of storing user session information on the server, you could store it in Redis. This way, any server can retrieve the necessary state information when processing a request, while the service themselves remain stateless. On the other hand, let's talk about the scaling in the stateful services. So scaling in the stateful services is a quite challenge, often requires using sticky sessions where a user is always routed to the same server that holds their state. Alternatively, you can use a sharded state storage like a database or a distributed cache, but this adds more complexity and can become a bottleneck. For instance, in an online game, you might use distributed cache to hold player state across multiple servers. This ensures that any server can access the latest player data if a particular server goes down. Okay, let's talk about when to let's talk about when to choose stateless or stateful services. So you should choose stateless when one of three. First, scalability is priority and you want to handle large numbers of independent requests. Second, the service's functionality can be fully captured in a single request response cycle. Third, you're building an API or service that's part of a microservices architecture where each service is responsible for a single atomic operation. Okay, choose stateful when you need to maintain session state for users like a chat apps or e-commerce carts. The service needs to remember past interactions to provide consistent experience. You're dealing with a real-time system that needs to track ongoing user actions, like multiplayer games or video and conferencing. So, okay, let's talk about a real-world examples. So, REST APIs are a great example of stateless communication. Each request is independent, makes it easy to scale horizontally. On the other hand, WebSockets are usually stateful because they maintain an open connection between the client and server, which is necessary for real-time feature like chat. In an e-commerce website, browsing products can be handled by stateless services, but when a user adds items to their cart or starts the checkout process, you need a stateful service to remember their selection. Okay. Let's talk about best practices for stateless and stateful services. First, let's talk about the keep services stateless when possible, because whenever possible, aim to keep your services stateless. This makes your system easier to scale, reduces complexity, and increases reliability. When you need to store state, consider externalizing externalizing it to cache or a database. Number two, you need to manage state efficiency in the stateful services. For stateful services, make sure to manage stateful efficiently. Use distributed storage solutions to avoid having a single point of failure and ensure that your state data is replicated across multiple servers. So, to wrap up, understanding the difference between a stateless and stateful services is essential for designing scalable and resilient systems. Stateless services are great um, are great for scalability, reliability, and simplicity. Stateful services are necessary when you need to maintain users' context or state across multiple interactions. The key is knowing when to use each approach depending on your application's requirements. And yeah, um, that's it. If you enjoyed this video, make sure to like it, subscribe, and hit the notification bell. And yeah, see you in the future.